I am Balaji Rao. Welcome to BR Maths class. In this class, we will learn definition of hyperbola and we will derive its equation. This is the definition of hyperbola. To understand this directly, you may confuse. So, first I'll explain few things. Later, I'll come back to this definition. You observe this diagram. I'll consider two important things. One is fixed point. This fixed point, I'll name it as S. Another one is fixed line. This is the fixed line. We'll name this as L. You consider points in a plane. In what way we need to consider? See here, the distance from point P to point S you observe. This is the distance from point P to fixed point, and this is the distance from point P to fixed line. SP by PM. This ratio is constant. Suppose SP1 divided by P1M, SP2 divided by P2M. Suppose this is point P1. You suppose this is point P2. SP2 divided by P2M. That means like this. This is P1M, P2M2. The ratio of these distances is constant. Suppose this ratio is 2. This ratio is also 2. And that constant ratio must be greater than 1. You need to consider points like that. As you already know the shape of hyperbola, but whatever here it is there, it looks like a parabola, right? But you please watch this till the end, then only you will understand the definition of hyperbola. Okay, here I'll consider point P. What I am saying here, SP by PM is constant and that constant is greater than 1. Okay, if you cross multiply as SP, PM are distances, SP is greater than PM. That means you observe here SP, this is the point P, SP is greater than PM. You take anywhere that you need to observe. That way only we need to draw the diagram. SP is greater than PM. Okay. Now to understand this more clearly, I'll take an example. You take point P here. Okay. SP, this is PM. I'll take this ratio as 4:2. SP is 4, PM is 2. What is SP by PM? SP by PM is 4 by 2. 4 by 2 is what? 2. This is greater than 1. This ratio is constant and that constant is greater than 1. Suppose if I take point P here, what condition it will satisfy? This is just an example. Randomly, I am trying to explain what is the definition of hyperbola. You take point P here, SP. This is PM. Here, this is 8. This is 4. Like that. Look here. Here, I'll write here. SP by PM. What is SP? SP is 8. PM is what? 4. 8 by 4 is what? See, the ratio is constant. Here also 2. Here also 2. Ratio is constant. And that constant is greater than 1. You need to consider points like that. You take any point in this plane, in this, you observe here, this blue color dots. You take any point here, its distances from fixed point and fixed straight line is constant and that constant is greater than 1 is called hyperbola. Okay. Now, actually, this shape looks like a parabola. Na? Actually, this is not the shape of hyperbola. The definition is not yet over. Here, these are the points I got now, like this. I'll get another set of points which satisfies the same condition. Okay, observe carefully. As we are discussing an example, look here, SP is 4, PM is 2 I taken just to explain the things. Okay, now you observe here, I'll consider here this length as 6. Here one more point will be there. Suppose if I take this point as P, SP divided by PM. See here, this length you observe SP. SP is what? 6 plus 2 plus 4. That is what? 12. SP is 12 divided by PM. PM is this one, the distance from this point to fixed line. PM is 6. SP by PM is 2. Try to understand. So here we got another point here also which satisfies the same condition. That you take point P here, the distance from this point P to fixed point and fixed straight line is constant and that constant is greater than 1. Suppose you take one more point here. See, this distance is SP. right? This distance is SP. I'll suppose this is 24. SP is 24. PM, I suppose this is 12, right? 24 divided by 12, that is 2. Try to understand. Another set of points also we are getting such that if you take a point P here, its distances, ratio of its distances from fixed point and fixed straight line is constant. That constant is greater than 1, right? Now let's see the definition of hyperbola. You see the definition of hyperbola, the set of all points in a plane such that ratio of its distances means from point P to ratio of its distances from fixed point and fixed straight line is constant, and that constant is greater than 1 is called hyperbola. So finally, whatever the shape you are observing here, this is the shape of the hyperbola. Now definition of hyperbola is over. Now we derive this equation. This derivation is very similar to ellipse derivation, right? Little lengthy, but if you understand that ellipse derivation, hyperbola derivation also, you can understand easily. This derivation is mainly divided into 3 parts. Part 1 is construction. Few things we need in this diagram to derive the equation of hyperbola, right? First part is construction. What is second part? What is third part? I'll explain in the process of this derivation. As you learn the definition of hyperbola, you need to know two things. One is fixed point, another one is fixed line. Fixed point is called focus. Fixed line is called directrix. You see here I written fixed point S is called focus, fixed line L is called directrix. You need to know what is focus, what is directrix in hyperbola, because while doing problems we use these words very frequently. What is focus, what is directrix. Now I'll take one point on the hyperbola. I'll take that point as P. Let P of x comma y is any point on the hyperbola. Okay, I'll write that point also. Look here, I taken P of x comma y is a point on the hyperbola. Now here eccentricity, this word we used in ellipse also. What is eccentricity? If P is this point, any point on the hyperbola, SP, PM, SP is distance from point P to S, PM is distance from point P to directrix. The ratio of these distances, SP by PM, the ratio of these distances is called eccentricity, which is denoted by E. In hyperbola, this E value is greater than 1. Okay. In ellipse, this E value is less than 1. In parabola, E value is equal to 1. What you are learning now? What is eccentricity? The ratio of distances from fixed point and fixed line is called eccentricity. You see here same thing we written, the ratio of distances from point P to fixed point S and fixed line L is called eccentricity. This is important. We use this word very frequently throughout this chapter. What is eccentricity? Okay. And eccentricity is denoted by E. In hyperbola, this E is greater than 1. In ellipse, E is less than 1. Okay. Now, I'll draw SZ passing through focus and perpendicular to directrix and intersects the directrix at Z. Okay. Look here, I'll draw like this. You observe, I'll draw SZ passing through focus, perpendicular to directrix, intersects at Z. You observe, I drawn SZ. Now same point we'll write. You see, draw SZ passing through focus and perpendicular to directrix. Now you observe this SZ cuts the hyperbola at 2 points. You observe here these 2 points. I'll take this point as A. I'll take this point as A dash. Okay. If you observe this A is a point on the hyperbola. Right? A is in between SZ. Okay. A is a point on the hyperbola and A divides SZ internal. SA divided by AZ is what? SA divided by AZ is the ratio of distances from a point on the hyperbola to the fixed point and fixed line, right? This ratio is eccentricity E. We can write it as E by 1. So A divides SZ in the ratio E is to 1. Okay. So SCA divided by AZ is E by 1. So here I want to introduce you 2 points, A and A dash. This SZ cuts the hyperbola at 2 points. One point I'll take it as A, another point I'll take it as A dash. If you observe this A dash is not in between SZ, but it is on the line SZ. It is on the line SZ, but not in between. So A dash is also point on the hyperbola, right? So SA dash divided by A dash Z. That means A dash divides SZ externally. This is also eccentricity that we can write it as E by 1. Okay. So you observe here, same point I written. A dash are the points which divides SZ in the ratio E is to 1 internally and externally respectively. That means A divides SZ in the ratio E is to 1 internally. A dash divides SZ in the ratio E is to 1 externally. Okay. Now you observe this A dash. I'll take midpoint of A dash. I'll take C. Let C is the midpoint of A dash. You name the midpoint of A dash as C and you take the CA as A, CA dash as C is the midpoint of A dash and you take CA as A, then what is CA dash? CA dash also A as C is the midpoint of A dash, right? And you see same point we written, C is the midpoint of A dash and CA equal to A. We are taking, you see here let C is the midpoint of A dash and CA equal to A, right? As we taken C is the midpoint of A dash, CA equal to CA dash. I hope things are clear to you. Now I'll consider few things in this diagram. See here, this SZ is there, I'll take this as x-axis and I'll draw a line passing through C and parallel to directrix, I'll take this as y-axis because these things are required to derive this equation of hyperbola. Okay. You observe same thing I written. Consider SZ as x-axis and line passing through C parallel to directrix as y-axis. Okay. So see same changes I done in the diagram also. X-axis, y-axis. As we taken CA as A, what is vertex C? What is this A? This A is A comma 0, right? And what about A dash? This length is also A, but this A dash is left side of origin. This A dash is minus A comma 0. We'll write the same point. See here, as we consider them as coordinate axis, A is A comma 0, A dash is minus A comma 0, and A dash, what is A dash? Distance between them is what? This length is A, this length is A. A dash is 2A. As I discussed earlier, A divides SZ in the ratio E is to 1. That we write it as SA divided by AZ is E by 1. Similarly, A dash divides SZ in the ratio E is to 1 externally. We write it as SA dash divided by A dash Z is E is to 1. Okay. From this, what is SA? SA cross multiply E times of AZ. From this, what is SA dash? E times of A dash Z. I'll take this as equation 1. I'll take this as equation 2. We'll write the same thing. You observe SCA divided by AZ is E by 1. SCA dash divided by A dash Z is E by 1. When you cross multiply this, what you will get? SCA equal to E times of AZ. SCA dash equal to E times of A dash Z. I taken this as equation 1. I taken this as equation 2. As I said, this derivation is mainly divided into 3 parts. From here, from this step, right? From this step to till here, part 1 is over. Now part 2 is what? Part 2 is very simple. I'll add equation 2, equation 1. Next, I'll subtract equation 2, equation 1. Whatever you will get from that, with that part 2 will be over. Okay, we'll start part 2 of this derivation. See, I am dividing this into parts. Actually, this is full derivation. To make the things are clear, you take this as part 1 of this derivation, part 2 of this derivation, part 3 of this derivation. Okay. Now I'll add equation 2 and equation 1. You add first left hand side part. What you will get? SA dash plus SA equal to right hand side part. What is there? E times of A dash Z plus E times of AZ. Okay. In the right hand side part, you take E common. What you will get? You will get A dash Z plus AZ. Okay. What is A dash Z plus AZ? Look here. A dash Z. Look here. A dash Z plus AZ. A dash Z plus AZ is what? It is AA dash. What is AA dash? We written here now. AA dash is 2A. This length is A. This length is A. Right? AA dash is 2A. So what I am trying to say, A dash Z plus AZ is AA dash. That AA dash is 2A. Okay. This is nothing but AA dash. That AA dash is 2A. Okay. Left hand side part, we'll do few tricky things, right? These things, why we are doing like this means these things are needed to derive the equation of hyperbola. What are the tricky things we are going to do in this? Yes, A dash. I'll write SA dash by including C. C is the midpoint of A dash now. Similarly, I'll write SA also by including C. How I can write SA dash by including C from the diagram? You observe this is SA dash. I want to write SA dash by including C. What I'll write? I'll write this as A dash C plus CS. I included C, right? So here A dash C plus CS plus this SA is there. Na? This SA also I'll write by including C from the diagram. You see here this is SA, right? This can be written as CS minus CA, right? CS minus CA is what? CS minus CA is SA, right? I hope you are understanding. As you know, CA, this is CA dash. CA, CA dash. These are distances. A dash, C or CA dash, both are same only, right? CA, CA dash are equal. You written. You see here, you written CA equal to CA dash, right? So here, what happens? The CA, CA dash are having opposite side. Na? They'll get cancelled. Then what is remaining? CS plus CS. CS plus CS is what? 2 times of CS. Now you observe this 2 will get cancelled. From this you will get CS. CS is AE. This is one of the important information. CS is AE. We are in second part now. In second part we added equation 2 and equation 1. We got CS. Now I'll subtract equation 2 and equation 1. Equation 2, left hand side part, what is there? SA dash minus SA. Right hand side part, E times of A dash Z minus AZ. Right? SA dash minus SA. Okay. Now, if you observe this SA dash minus SA, what is SA dash minus SA from the diagram? You observe SA dash minus SA. You subtract this SA. SA dash minus SA is what? SA dash minus SA is AA dash. It is clear. What is AA dash? AA dash is 2A. So left hand side part of this, I can write it is AA dash. AA dash is 2A. Now, in this right hand side part, we'll do the tricky things. A dash Z is there. Na? I'll write this A dash Z by including C. AZ is there, na? That I'll write by including C. Okay. E times of A dash Z. You need to write this by including C. You observe the diagram, A dash Z. A dash Z. You need to write by including C. How you will write? C A dash plus C Z, right? We can write it as C A dash plus C Z. Okay. Now this AZ is there, na? That I want to write including C. AZ. Observe the diagram. I want to write this AZ by including C. How we can write? We can write it as CA minus CZ. CA minus CZ is AZ. Now observe this minus CA plus CA dash both will get cancelled, right? So what you will get in the right hand side part? E times of CA dash. You know the CA dash CA both are same, they will get cancelled. Now you see minus of minus will become plus. CZ plus CZ is 2 times of CZ. Now see this 2 will get cancelled. From this you will get CZ. What is CZ? CZ is A by E. This is second important information. As you got CS as AE, from this you can write focus. See here, C is origin, CS. You got this CS as AE, as this length is AE. What is S? S is AE comma 0, right? We'll conclude this second part. As we got CS equal to AE, from this we can say that S is focus. S means focus. Na? S is AE comma 0. This we use as a formula in this chapter. Focus of hyperbola. S is AE comma 0. Now you got this one, na? CZ equal to A by E. From this we can write equation of directrix. See, yes, this is directrix. This directrix is parallel to y-axis. So, if any line is parallel to y-axis, its equation starts with x equal to. This length is a by e. As it is at a distance of a by e units from y-axis, we will write x equal to a by e is equation of this line. So, equation of directrix is x equal to a by e. And one more thing, we can write what is PM. You see here, this is PM. We can write what is this length. As you taken P as x comma y, you observe this length is x. As P is x comma y, this length is x, this length is y. Okay. Now, I want to write PM. I want this length PM. As this full is x, as you know CZ, what is CZ? CZ is A by E. So, what is PM? PM is x minus A by E. With this, second part is over. See, second part started from here, equation 2 plus equation 1. And in this we got S and we got this PM. Okay. Now third part, actual derivation starts here. You know, as per the derivation, eccentricity is what? SP by PM. See, here P is a point on the hyperbola. What is eccentricity? SP, ratio of distances from point P to fixed point and fixed line. You observe SP by PM. SP by PM is what? Eccentricity, right? You observe here SP by PM is E. In this eccentricity, this E value is, in this hyperbola, this E value is greater than 1. Okay, SP by PM is E, E is greater than 1. Okay. If I simplify this, what I will get? SP is E times of PM. Okay. What is S? Here you see, S is AE comma 0. What is P? P is x comma y. S is AE comma 0. P is x comma y. Now you use the distance formula SP, root over x2 minus x1 whole square plus y2 minus y1 whole square is there. Use that formula SP. You know point S, you know point P. Distance formula you use, what you will get? X minus AE whole square plus y minus 0 whole square equal to E times of PM. What is PM? PM is x minus A by E. Okay, now use square on both sides. You observe here, if we square on left hand side part, this square root and this root will get cancelled. Okay, so what you will get left hand side part? X minus AE whole square plus y minus 0 is y square equal to e square into x minus a by e whole square. Okay. Further, you simplify this, expand this, x square plus a square e square minus 2aex plus y square equal to e square times of x square plus a square by e square minus 2 times of x into a by e. Okay. Now, right hand side part you multiply with e square x square plus, see, when you multiply these two, this e square will get cancelled. You will get a square minus, and you see, when I multiply these two things, 1e will get cancelled. You will get 2aex, 2aex. Now you observe, can we cancel any terms? Yes, here minus 2ax will get cancelled. Okay, I'll make few changes. Please observe carefully. This e square x square, I'll keep it here only. This x square, I'll take it to the right hand side part. This is important. This plus x square will become minus x square. Okay. Now this y square is there. This y square also, I'll take it to the right hand side. Then this will become minus y square. Now here a square is e square is there, that I'll write a square e square. Now here plus e square is a square is there, you take it to this side, this will become minus a square. These changes are compulsory. You need to make it like this only, otherwise you will end up with big confusion. Okay. There is a small trick in this to do like this. If I say now, you may confuse. At the end, I'll discuss. Okay. Now, in the left hand side part, you take a square common. Then you will get a square into e square minus 1. In the right hand side part, in these two terms, you take x square common. E square minus 1 into x square minus y square. Okay. Now, e square minus 1 into x square minus y square equal to a square into e square minus 1. I can write like this just for our convenience. X equal to y, I written as y equal to x. Okay. Now, to get the equation of hyperbola, I'll divide this complete equation with a square into e square minus 1. I'm dividing this complete equation with a square into e square minus 1. Okay. Y square divided by a square into e square minus 1 equal to a square into e square minus 1 divided by a square into e square minus 1. See, this 2 will get cancelled. This e square minus 1 will get cancelled. What you will get? You will get like this: x square divided by a square minus y square divided by, here this part is there, na? Y square divided by a square into e square minus 1 equal to 1. Actually, this is the equation of hyperbola in standard form. But we'll make it little simpler, right? By taking this as b square, right? We'll take this as b square. Okay. X square divided by a square minus y square divided by b square equal to 1. What is b square? You must and should specify here. B square is a square into e square minus 1. So x square divided by a square minus y square divided by b square equal to 1. What is this? This is equation of hyperbola. In this, what is b square? B square is a square into e square minus 1. So from now onwards, this is called equation of hyperbola in standard form. Now you need to know one important point. This hyperbola is symmetrical about coordinate axis. Right? You observe this hyperbola diagram. This is symmetrical about coordinate axis. Right? This part is same as this. Because of this symmetry, same diagram you will get. See, actually, we taken this as a fixed point, this as a fixed line. As per the definition we proceeded, we got this diagram. Same diagram you will get if you take this S dash as a fixed point, this L dash as a fixed line. If you proceed further also, you will get the same diagram because of this symmetry of this hyperbola with respect to coordinate axis. So because of this symmetry, this hyperbola will have two focuses, right? We call them as foci. So S dash are the foci of the hyperbola, and this L dash are the directrices of the hyperbola. So hyperbola will have two focuses and two directrices. I hope you understand this question. What we learned, definition of hyperbola, and we learned what is focus, what is directrix, what is eccentricity, and we derived equation of hyperbola in three parts. Here, this third part starts here and till the end, right? So this is derivation of equation of hyperbola. So what is the conclusion? The conclusion is x square divided by a square minus y square divided by b square equal to 1 is the equation of hyperbola, where b square equal to a square into e square minus 1. Whereas it comes to ellipse, x square divided by a square plus y square divided by b square equal to 1. Ellipse I am saying, where b square is a square into 1 minus e square. I hope you understand this class. If you like this video, please drop a like, share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye.